calcite. The thing they're looking for is calcite from planet Gorman. And so I thought about it because I encountered it at work, or similar crystals. Okay. So calcite, first, what is calcite? Let's get one search less than this. Calcite, a common naturally occurring mineral, the most stable polymorph of calcium carbonate. Calcium carbonate, I recognize as chalk.
Okay.
So it's at least the same chemistry. Yeah, let's get a little bit lower. Calcium carbonate, so carbon 3 oxygens. I guess it can look like this milky white stuff, or it grows as these crystals.
Yep.
I encountered it by accident. Like I was looking this up the next day for work stuff. Calcite, when it's real clean, real crystalline, it exhibits a high degree of birefringence. Let's zoom in on this. Calcite exhibits a high degree of birefringence, meaning it refracts light differently depending on the direction of the incoming light and the orientation of its crystal structure. So it's specifically as a function of polarization. So here's a line, single line. Let's pull this into the middle. Close enough. So a single line, and then the word calcite written once, but it creates a double image. So if you have light that's polarized, it's a wave, but it's not only a wave going up and down, it's side to side. So it's, I don't know, snake horizontally at the same time as bunny hopping up and down. And so calcite, which has this birefringent property, means the index of refraction is different depending on which polarization you get. And so the result is that you get two optical pathways. One light ray comes in, two light rays come out. Mm-hmm. And so why was this interesting to me? It caught my attention because these guys are setting up for the Death Star, in which case you have these huge lasers. Mm-hmm. And so crystals with birefringent properties are used in optics with lasers.
Okay, so somehow the calcite is being... Huge quantities of calcite are needed to build a huge laser on the Death Star.
Exactly.
And the optical properties of calcite are being used to focus the beams, do something with the beams, so they can use the huge weapon. That makes sense to me. That's kind of cool.
That's some science details in Star Wars. Mm-hmm. Heck yeah.
My only issue with calcite is if I look at the elements in calcite, like calcium, carbon, oxygen. These are fairly common in the solar system, on Earth at least. I would imagine they're fairly common in the entire galaxy. Like you could find planets without people on them with plenty of this.
So calcium and carbon, I think, are easy chemistry because they're formed in the star fusion. So you get a star that explodes, and these things are splashed all over. Same with oxygen. I think the difficult thing. Let's see. I listen to a podcast. Oxygen in the atmosphere is rare to come by on planets because there's a bunch of different rocks, a bunch of different minerals that pull oxygen out of the atmosphere. And I guess actually this is an example. Calcite is made out of calcium, carbon, and oxygen that's pulled out of the atmosphere. So I guess I agree with you then. Yeah, these should be pretty common. Why do you got to pull it out of Gorman?
Maybe like with these rocks though, if you're looking at this picture here, there's like the orange one and the blue one. Maybe there's a specific type of this calcite with it's got a specific doping and different things that make it this particular. What's that?
I think no doping is what you want. So you're talking about doping in the form of like ruby, crystal.
Yeah, I guess I'm saying maybe there's calcite and there's a whole bunch of different types of calcite because these rocks are always complicated. And maybe the Empire is looking for this one specific type of this calcite, like very specific, and only this planet has it. And maybe that's the key.
Maybe. So
why this planet and not just find an uninhabited planet is.
We just said a bunch of things. Maybe we should slow that down. So there's aluminum oxide, and depending on the doping, you get like ruby or sapphire or emerald, and it's all the same aluminum oxide, but with little bits of other stuff, little like tiny dopants. So we're talking about
Yeah.
like one per every million aluminum atoms. You substitute it out with I don't know, something else, you get sapphire. And so then
Right.
you're saying for this calcite, maybe there's only on Gorman do you get this really pure stuff, which is then what you need for the optics in the Death Star.
Yeah.
Yeah, maybe.
I wasn't even thinking, it wasn't necessarily pure. It could be they need a non-pure version where they need a very specific version of it.
This chemistry.
And it's only found. It could be the pure version. It could be some specific doped version. Whatever it is, it must be uncommon in the quantities they need. I'm filling in some blanks here. I don't know.
I'm filling it. Yeah, absolutely.
Yeah.
Also filling in blanks. Let's see. I've seen this before. I think it's KOP. I forget what the KOP stands for, but it's these.
KOP.
Right. Maybe it's KDP. KDP crystals. Potassium dideuterium phosphate. So I learned about this at the National Ignition Facility at Lawrence Livermore, their fusion reactor, and so they needed their fusion experiment, and they have lasers that are focused in by these crystals, but the lasers are like 2-3 feet in diameter, so you need crystals. You need like pure, perfect crystals, no extra dopants, no extra and no folds in the crystal structure. It's got to be clean. And so these things don't happen in nature. And so they're grown. They're actually here's a human. This thing is all one crystal. And that means every atom is positioned exactly where it needs to be. That's just absolutely insane. And the way they do it is, see down here is this, so blurry. But you see down here, there's a little not transparent spot.
Yeah.
It's a seed crystal. So you can grow small ones and then grow them bigger. And then you put this thing in a solution of, what was it? KDP, potassium, deuterium, and phosphate. You make a liquid slurry out of it. So you take these materials independently, grind them up, dissolve them, and then you slowly evaporate it, just like when you put sugar water and you put a string and then it evaporates and it slowly makes a sugar crystal. Similar idea. There's quite a bit more engineering to it, but you can grow these macro scaled perfect crystals. Look at this guy. Look at this guy standing next to them. Yeah. Incredible.
So for the Death Star, they must need this calcite of this particular type in huge quantities to build probably crystals the size of skyscrapers or something absurd, because the Death Star is enormous.
Right.
Yeah. To be able to handle the power of those lasers that could destroy a whole planet.
Exactly.
That's pretty cool.
Pretty cool.
I mean,
very nicely done.
Cool.
Science advisors in the Andor show. Very nice. Very nicely done.
Mm-hmm. Because planet-killing atrocities are fun.
Okay. Yes. No. But scientifically accurate? Yes.
Yep.